All right, hi everyone. This is the next property we're looking at. It's called the division, and that's because there's division happening between my x's. Okay, so let's hand write out what they mean, and then that'll lead us to the actual property itself. So if we take a look, x to the fourth means that I have four x's on top and then two on bottom. Now, something that you might not know is that when we have the same thing on top and bottom, we can cancel them out. What I mean by that is I have this x, I'm going to do this in a different color so it stands out. I have this x and this x. If I cancel them out in pairs, they can be canceled out. So I have a top and bottom and top and bottom. So what's left is I have x squared on top. Hmm, maybe there's a relationship between the 4 and the 2 and the 2. Let's write this one out. We take a look. 1, 2, 3, 4, 5, 6, 7, 8. Now you can see where this starts to get tedious because who really wants to write out 8 or more x's? Okay, so I write them all out. And now, time to crisscross out in pairs. Gone, 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 gone. So my final answer is x to the 3. What's the relationship between 8, 5, and then the 3? Last one. 3 x's, 2 x's, cross them out in pairs, and what I have left is x, or x to the first. So hopefully you can kind of see the relationship, but if we take a look, for any number m, when I divide it by any number n, I can just subtract their exponents. Now, what I mean by that is, so say, for example, x to the 50th over x to the 30th. Well, are you really going to want to write 50 n's and x's and 30 x's? No. And then cross them all out? No. You're just going to say 50 minus 30 is 20. And that goes back to the whole chutes and ladder concepts. You can do it piece by piece and go every square. But if you know the property, aka can land on a ladder, it'll get you there much quicker. Okay, so let's do a couple examples. I'm going to use the property. So if we take a look, 2 minus 1 is x to the first. 6 minus 3 is x to the third. 7 minus 10. Now, this is a good one to show. I'm going to write these out. So there's 4, 5, 6, 7. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I cross them out, right, I cross them out in pairs, and what's left should be, maybe I miscounted, but there should be 3 on the bottom. Okay, so if we take a look, the bottom has more, so my answer is going to be the bottom on the fraction. Okay, so if I cancel out everything up top, it's going to be a 1 because that's a placeholder. If it was 0, the whole fraction would go away. And then there's 3 on the bottom. So let's take a look. Remember that sneaky exponent here is a 1. 3 minus 1 is x squared. And 7 minus 5 is also squared. So there's my answers. Okay. Last bit, combination with coefficients and letters again. So if we take a look, if I just crossed out and pretended they weren't there, this problem, when I read it out loud, says 10 divided by 5, which the answer, 10 divided by 5, is 2. So now I'm going to do the exponent properties. 7 minus 3 is 4. If I pretend I have no x's, 40 divided by 2 is 20. And now 3 minus 2 is 1x. Okay, now this is a good one to look at. Now we use that simplifying button on the calculator, n over d. If we typed in 4 over 8, it reduces to 1 over 2. So we're going to write it as that fraction. Now I just erased the, because I didn't want to have the circle up top. So 1 over 2. Now let's look at our x's. 7 minus 2 is 5. And now, so that's positive 5, so it's going to stay on the top. And 8 minus 3 is going to be also positive 5. If I wrote those all out, if I did 7 x's, 3, 4, 5, 6, 7, and 2 on the bottom, if we take a look, there's 5. And where are they physically? They're on top of that fraction bar, so that's where they should end up. Okay? All right, so check out the next video in the series. It's going to be about negative exponents.